everyone. Today we are looking at the part 2 of our sequencing and scheduling. If you remember, in the part 1 video, we schedule our jobs using 4 priorities: earliest due date, shortest processing time, longest processing time, then first in system, first served. Today we are moving further, looking at what we call more procedure. And the essence of more procedure is to look at how we can reduce the number of delayed jobs. Looking at the first video, the earliest due date gave us 4 tardy jobs. 4 jobs were delayed using earliest due date. And as a businessman, the essence of being in business is to make profits and to also see as much as possible how you can retain your customers. Now, if you are fond of delaying your customers or delaying their jobs, there's probability of you losing them or losing revenue. Now, more procedure has come to see if there's any way or if it is possible to reduce the number of delayed jobs. And in doing that, we start with earliest due date. Now, there are some steps we need to follow using more procedure. The number 1, as you can see on our screen, says arrange the jobs in increasing order of their due date. That means from your earliest due date schedule or sequence. And if you go back to the first video, our jobs were sequenced in this order: job 1 before job 2, job 2 before job 5, in that order. This is the EDD schedule. If this EDD schedule produces 1 or 0 tardy job, then it is optimum solution. If it has given us a single delay job or 0, then we don't need to look further. More procedure has come what? To see if it is possible for us to reduce the number of delay jobs. Now, the step 1 again is to arrange our table in EDD schedule format. Step 2 says what? Identify the first tardy job in the EDD schedule. Now, if you look at it, the first tardy job is job number 2. That is where the first delay came into. Job 2 was the first job we delayed in this sequence. So we look at it, then they have brought out what? Bring out the EDD, the completion time, the due date. The first tardy job in our example is job 2 with the completion time 13, which is this. Now, and the due date of what? 10. Look at the due date. That is why it has been what? It has been asterisk. Step 3 is telling us that from among the jobs up to including the first tardy job, the one we have asterisk, which is job 2, they said, well, we should pick the job with the longest processing time. If you go by the processing time, look at the processing time. We want the longest processing time. Look at it, which is job 4, has the longest processing time. Jobs 1 and 2 with the processing time 5 and 8 respectively. Now, the essence of the more procedure is because if you look at job 2, that we had the first delayed job, how many hours did it take us to do that? Look at what we have on the screen. This is the earliest due date sequence, job 1 in this order. Now, if you look at this, job 2, can you see this is where the delay started from? We delayed job 2. Because we delayed job 2, look at all the other jobs. We delayed job 5, job 4, job 3. Now, that's okay. Step 2 now says that let us look at the processing time for all these jobs. Which one has the longest processing time? You can see clearly that job 4 has the longest processing time of what? 9 hours or 9 days. Now that means for us to have delayed job 2 that has 8 days or 8 hours, it depends on the parameter whether it's 8 days or 8 hours. That means any job after the 8th hour or the 8th day will further be delayed. That means maybe the machine is unable to process any job that is what that is 8 or beyond 8 hours or 8 days and beyond. That means it's possible for the machine to be able to do what? The job that is within 6 days or 6 hours. It's possible for the machine to be able to do the job that is within 3 days or 3 hours. It's also possible for the machine to do the job that is within 5 days or 5 hours without delaying them. But because we have gone ahead using our EDD to say, okay, let's start what? After job 1, let's do job 2 that is taking 8 hours. And the job has been delayed. So that's okay. If you look at this, let's take away what? The first delayed job. If you take away the first delayed job, which is job 2, let's now take job 1, job 5, job 4, and job 3. Let's do the sequence again. Whether we are still going to delay any other job. Now, job 2 has been taken away from our what? Out of the sequence. Now we are left with job 1, 5, 4, and 3. Look at the processing time the way we have in the original table. The due date the way we have in the original table. Now the completion time is what? This is 0 plus 5. Remember, that is 5. So now look at 5 plus 6. This gives us what? 11. The same way we have been doing. 5 plus 6, 11. 11 plus 9 gives 20 plus 9. 20 plus 3 gives 23. And our flow time, as I've said, you follow the pattern of your completion time. Repeat what you have your completion time. You have repeated it. Now look at the third jobs. There's no, here we are comparing what? Our due date with what? Versus our what? Completion time. Due date versus completion time. If the due date is greater than completion time, what do we call that? There's no what? No delay. So there's no delay. However, if your due date is less than your completion time, equal to what we call that, that is what? Delay. Now look at the due date 7 and look at the completion 5. The due date is greater than the completion, there's no delay. The same thing in job 5. Look at the due date 16, look at the completion time 11. So there's no delay. But go to job 4. The due date is 18. Look at the completion date 20. We delayed this job for 2 days. Job 3 also was delayed for what? 2 days. Now let's look at here. We still have how many delayed jobs? We still have 2 delayed jobs. At this point, we are not yet at what? Optimal level. Don't forget, you are given 5 jobs to do. What we are doing here is we are looking at the job that delayed us or the jobs that we delay. If, for instance, we are not doing the job first, what if we make it the last job to do in the sequence? Are we still going to delay them? Now, let's take away job 4 again. That means the delay started from job 4. And if you look at the processing time for job 4, it's still the highest out of the 4. So that means if look at the jobs that we did within less than 9 hours or 9 days, we didn't delay them. That means if you have done job 3 before job 4, maybe we will not even delay job 3 because the job 3, the processing time is still what? Within 1 to 8. Now let's look at it. Let's take away job 4. I've highlighted job 4 here because the delay started from this what? This job 4. So we want to take it out and see how whether if you do job 1, job 5, and job 3, if you are still going to delay any job in that order. Look at the results. In that 1, 5, 3, can you see? Don't forget how we arrive at all this. If you look at the whether there is a delay job, Look at the processing, the due date for job 1, 7. We completed it on the 5th day. No delay. You can see that we didn't delay these 3 jobs, because if you look at the processing time, they are what? Less than 8 hours or 8 days. It depends on what we are given. Because the first delay job, job 2, the processing time for job 2 was 8 hours and we started the delay. You can see that none of these 3 jobs was what? Still what? 8 hours. They were beyond or below 8 hours. That means we didn't delay them. That means if you have done the jobs in this order first, job 1, job 5, job 3, we will not delay them. But what we did in our earlier EDD, we did job 1, then we went to job 2, we went to job 5, job 4, job 3. But because we delayed job 2, it affected all other jobs. But we have seen that job 2 with 8 hours, job 3, since you delay the first job at 8 hours, any hour beyond the first delay job, any hours beyond this, job 4 gave us what? 9 hours. This job 4, it gave us 9 hours. We delayed it. So you can see that job 1, 5, 3, no delay. Then don't forget the jobs that we removed from the initial table, job 2 and 4. We need to now bring them back to see if we do job 4 after job 3, are we going to delay? Bring them back to the original table. That's it. Job 1, 5, 3. Then bring job 2 before job 4. Let's say if you do job 2 before job 4, are we going to delay? It's okay. Look at it. This is completion plus 5. So this is 5 plus 6. This is 11 plus 3. This is 14 plus 8. Why this is what? 22 plus 9. Now, the tardy, don't forget, if our due date is greater than what? The completion time. This is what? No delay. If it is the other way around, if the due date is less than the completion time, this is what? Equals to delay. Now look at it. No delay here. But look at job 2 again. Look at the complete due date 10, completed on the 22nd. We delayed it for 11 days. Also this, the due date is what? Lower than what? The completion date or time. We delay it for 14 days. If you can see that, now we are having 2 delayed jobs out of the original 4. Now we brought job 2. Note this. We brought job 2 before job 4. Now if we add the 2 tardiness together, this will give us 25 hours or 25 days. It depends. Now, what if we do job 4 before job 2? What will be the total tardiness? Let's check. Now, we have brought job 4 here before job what? Job 2. Don't forget, you have agreed that doing this 3 jobs first will give us what? No delay. Now, we have seen that the due date for job 4 is 18, while the completion date was 23. So we delayed this job for 5 days. While for job 2, the due date is 10, completion time 31. We delay for 21 days. Look at the total tardiness. Is what? 21 plus 5. This gives 26. That means either way, whether you do job 2 before job 4 or job 4 before job 2, you are still going to delay the 2 jobs. But they are not giving the same tardiness. So the total delay jobs are 2. The total is what? 2. But how many is what? The delay what? Tardiness. The total tardiness. 26 in this case. The other one did not give us 26, gave 25. Now let's look at the decision. Now if you look at our first sequence, the first one where we arrange our job in 1, 5, 3, 2, 4, the total tardiness gave 25. Why the second one doing job 4 before job 2, the total tardiness gave was 26. So That means we are still going to delay the 2 jobs. We have reduced from 4 to 2. At this point, we pick the one with what? Lower tardiness. Now, the essence of this is this. Now, if you are to pay $2 per what? Tardiness. In this first scenario, you are going to pay what? You are going to pay $50 as penalty. You are going to pay 50 as penalty. While in the second case, it will be 26 times 2. So that's what we are going to pay. So that will give us what? 52. So we are going to pay more. So you go with the one that what will reduce your cost. You can see that we have moved from what? 4 delay jobs to 2 delay jobs using what? More procedure. That is the end of more procedure. Now, what we have looked at in this table, in the first video gave us was the order priority, EDD, earliest due date, shortest processing time, longest processing time, then first insisted, first served. This second video is taking us towards more procedure, and they all look at what? When you are using a single machine. Now, in life, you may be using what? More than one machine. What if you are using 2 machines? How do we solve it? What do we do? Well, you have 2 machines to use, and you know for every idle time, there's a penalty. You don't want any machine to be idle. So we look at how to process a job using 2 machines. How to process a job using 2 machines is talking about what? Johnson's procedure. This is Johnson's procedure. This is Johnson's procedure. Step 1 says, determine the minimum processing time on either machine. The minimum processing time. That means we'll be having more than one machine here. Step 2, Roman figure 1 says, if the minimum processing time occurs on the first machine, denoted as what? M1, first machine, place the associated job in the first available position in the sequence. Now, if the minimum processing time occurs on the second machine, denoted as M2, we place the associated job in the last available position in the sequence. What do we mean by this positioning? How do we position? Step 3 says, go back to step 1 and repeat the process until all the jobs are sequenced. So we do this from step 1 to step 3. Let's see how this is been. Now let's look at what we have here. Now let's look at this jobs 1 to 5. Look at the processing time in hours. Machine 1. The job 1 will spend 5 hours in machine 1. That same job 1 will spend 3 hours in job 3. Job 2 will spend 1 hour in machine 1, 6 hours in machine 2. The same way for job 3, 4, and 5. Now, let's look at step 1 says, what do you have in step 1? Step 1 is telling us that we should determine the minimum processing time on either machine. The minimum processing time. Look at the minimum processing time. Okay, this is 1. 1 is the minimum processing time. Where do you have it? We have it on job, which is job 2. It's on machine 1, because the minimum process time is what? On machine 1. So that means we are going to place it here. It will be what? Sorry, it's going to be job 2. So job 2 will be placed here. Now we take this what out. Then you look at the next minimum processing time. After 1, anyone? No, 2. The next one is what? 3. Now we can see the 3 that we are having. We have 1 under machine 2 for job 1. We have another 3 under what? Job 4 for machine 1. Now that means this is a tie. How do we break the tie? In case you have a tie, how do you break it? Look at the rules for breaking what ties in Johnson's method. Equal minimum processing times occur from different jobs, one for each machine, machine 1 and 2. The case you are trying to look at. That means if you have the equal minimum processing time, what you are looking at, you have 3 hours processing time on job 1, which is on machine 2. Then the 3 processing hour, we also have it on job 4, which is on machine 1. That means there's a tie. We say, well, place the job on machine 1 first on the sequence and the one on machine 2 last. So we place the job on machine 1 first. Don't forget there's a tie here. There's also what a tie. Job 1, the 3 hours processing time is on what? Machine 2. While job 4, the same 3 hours processing time is on machine 1. They say what? You should place the job on machine 1 first. That means job 4 here. Then we'll go back from the back. Place what? Job 1 from rear. That means this out, this out. After 3, the next process time was job 4 is 4 hours. Because after 3 is 4. But the 4 is on which what? Is on machine 2, which is job 5. So since it's on machine 2, we start from the back. So this is out. The next processing time after 4, we have 5, but there's 5 is out, 6 is out. The next one is 7. Where do we have the 7 processing time? The 7 hours. We have it on machine 2. We start from the back. So that means the job is going to be in this order. 2, so you take it out. It's going to be in 2, 4, 7, 5, 1. The job is going to be placed in that order. Now we have arranged this in that order. Now look at job sequence. Job 2, 4, 3, 5, 1, as we have it here. Now for machine 1, it will have in, it will have out. Machine 2 will also have in, it will also have out. Now we need to also look at the idle time for each of the 2 machines. Remember, you don't want to have any idle time. No, at no point should any machine be idle. Now, job 2, which is the first job we have in our sequence, will come in at what? At time 0. Now look at it, job 2 will come in at what? Time 0. How many hours is it going to spend in the machine? It's going to spend what? 1 hour. So that means it's going to be out what? Is 0 plus 1. It will be out what? In 1 hour's time. That means the out time in machine 1 for job 2, it will come into job 4. The out time will be the same in time for the next job. It will come in at what? 1 hour. How many hours is job 4 going to spend in machine 1? It's going to spend 3 hours. This is what? This 1 plus 3. The next job is job 3. It will come in, the out time is 4. It will come in at 4. It's going to spend 9 hours. So it will be 4 plus 9. It will be out 13 hours. It will enter job 5 at 13 hours. So in job 5, the machine is going to spend 10 hours. On machine 1, the job is going to be what? 13 plus 10. That will be 23. Now the out time is 23 hours. It's going to enter the last job, job 1, that same hour. And it's going to spend 5 hours on machine 1. So it will be 23 plus 5. That is 28. Now, for machine 2, don't forget, as it's leaving machine 1, is entering machine 2. So, as it's leaving, the job is leaving machine 1 in 1 hour. In that same hour, is entering what? Machine 2. And how many hours is it going to spend in machine 2? The job 2 is going to spend 6 hours. So this will be 1 plus 6. The out time will be the same in time for the next job. It's entering at what? 7th hour in job 4. And it's going to spend 8 hours. It will be 7 plus 8. The out time, the same as the in time for job 3, where it's going to spend 7 hours. 15 plus 7, 22. Now, this is where we need to be careful. Don't forget that the job 3 is out on the 22nd hour from machine 2. Now, it's supposed to enter immediately into job 5. But look at machine 1. Machine 1 finished job 5 at the 23rd hour. Though machine 2 finished what machine 2 was processing, job 3 it was processing on the 22nd hour. It will not get the next job from machine 1 until machine 1 finishes work on it. That means machine 5 finished the work on job 5 at the 23rd hour. That means machine 2 we have to wait for additional 1 hour to get what? The next job. So that means machine 2, after finishing job 3 on the 22nd hour, he waited for additional 1 hour to get what? Job 5. That is where what? It was idle here. Now, the time we are going to record for job in time for machine 2 for job 5 will be what? 23, which is the time machine 1 finish what? Job 5. So it will be what? 23. And he's going to spend how many hours on machine 2? He's going to spend what? 4 hours. It will be 23 plus 4, 27. Now, look at here also. It has finished job 5 on the 27th hour. Now, job machine 1 was working on job 1. So it finished what? That on the 28th hour. That means machine 2 that finished work on job 5 on the 27th hour was waiting again for machine 1 to finish this. It will not enter at the 27th hour because it's going to enter at what? 28th hour. 28th hour, and it's going to job 1 will spend how many hours in machine 2? It's going to spend 3 hours. So it will be what? This 28 plus 3. This gives us what? 31. So how do we calculate the idle time? Job 2 that got to machine 1 and is spending 1 hour. That means machine 2 was waiting for what? 1 hour, because it will not start working until it gets the job from machine 1. Machine 1 said, okay, I'm working on this job for 1 hour. That means wait for that 1 hour until I finish. So this is what was idle for 1 hour. It was not idle here because immediately the job left machine 1. It immediately was through with job 2 here. Immediately took another job. Here, the time out is enter into the what? The timing for the next job. Here, he finished this job 3 on the 22nd hour. But he had to wait for machine 1 to finish job 5 on the 23rd hour for it to what? To take the job. So from 22 to 23rd, he waited for what? Additional what? 1 hour. So the waiting was not here. That's why we have not recorded it here. The waiting was for what? For job 5. We're waiting for, he's done what with job 3. He's not waiting for job 3. He's waiting for job 5. That's why we have it here. Now again, it finished this, the machine 1 finished job 5 at the 27th hour. But machine 1 did not finish job 1 until what? 1 hour after. That means on 28th hour. So between 27 to 28, he waited for what? Additional 1 hour. So that means the 1 hour he's waiting was waiting for job 1. That's why we have 1 hour here. Now, since we have 2 machines, machine 1 finished job 1 on the 28th hour. But since it's a batch, Now, machine 1 done with job 1 on the 28th hour, but for machine 2 to complete the job, machine 1 had to wait for 3 hours. That means it finished on the 28th, he had to wait for 29, 30 and 31. He waited for what? For 3 hours for the job to be completed. That is how we calculate what? The idle time of the machine. In another scenario, let's look at this. If you have 2 personnel working shifts, that means the person that's going to hand over to the other person must finish before the next person gets the job. That means you started the job at 0 hour, you are going to spend 1 hour. The next person you are going to hand over to have to wait for 1 hour for you to finish before you will start working on that machine, on that job. So it was idle for 1 hour. Now let's look at the idle time here also. The person was through with job 3 on the 22nd hour, but because the person runs shifts with the first person, for him to get the next job done, he has to wait for the first person to finish. This person now finish what? The job on the 23rd hour. That means you have to wait for 1 hour to get the job. Here also, after you have finished on the 27th hour, the next job to be done, which is job 1, you have to wait for the first personnel working on it to finish on the 28th hour. You cannot take the job on your own because you have to wait. It has to be passed on to you. The job was passed on to you on the 28th hour. That means you waited what? For another 1 hour. Since you are running the shift together and nobody can say, okay, I'm done with my shift, I'm going. You have to wait for the other person in the shift. So you finish that job. The first personnel finish on the 28th and it pass on to you on the 28th. But for the 2 personnel to say, okay, we are done with our work for the day, the person had to wait for the last job in the batch to be done, which is what? On the 31st. So the 31st hour you finish what? Everything you have to do in that batch. That means you waited for 29th, 30 and 31. You waited for 3 hours. You were idle for 3 hours. So now we have come to the end of the second video. The first one, we talked about using priority, earliest due dates, first in system, first served, shortest processing time, longest processing time. Using these 4 priorities, let's sequence our jobs. Then we look at more procedure which came to salvage the number of delayed jobs. If the number of delayed jobs is just 1, then you are at optimal level. But if the number of delayed jobs are 3, 4, then you need to introduce more procedure. Then when we are talking about 2 machines, we are looking at Johnson's rule. How do we sequence our job using Johnson's rule? Thank you. We have come to the end of the video. Please subscribe to Presi Tutors. Anytime we have new videos, you get notifications. We are in this to help our students to ensure you succeed in your master's program. Thank you.